Sweta Kotha. She's a data scientist at TIPCO, and she's going to talk to us about renewed energy, innovating with data and machine learning in energy. The volume and variety of data are particular challenges in the energy industry. Sweta Kotha, a data scientist at TIPCO, will share real-world use cases for AI in oil and gas and renewables. She's going to tell us how she's addressed these challenges. She'll highlight practical approaches in the AI lifecycle, from data scalability to predictive insights. Sweta studied statistics and machine learning at Carnegie Mellon University, and her analytics experience in other industries span natural language processing and biostatistics. All right, without further ado, I'm going to go ahead and bring Sweta up on our virtual stage here. Hello, welcome to the DATAcated Conference, and thank you for joining us.
Hi, Kate. Thank you so much for having me.
Absolutely. I'm going to go ahead and remove myself from the stage and let you take this away.
Awesome. Can you see my screen up?
Yep, we can see the screen.
Okay, awesome. Yeah. So again, I'm very excited to kick off the energy section of this conference. And today specifically, I want to show and tell the story of a data science project in renewable energy. And today I'm going to be working with data from the Electrical Reliability Council of Texas and the National Oceanic and Atmospheric Administration. And again, we're going to bring together intuitive visualizations and complex analytics. But again, since I'm kicking off the energy section of this conference, I did want to give an overview of the industry itself. So oil and gas development are really at the forefront of the energy industry. The volume and variety of data that needs to be constantly assessed and monitored in oil and gas poses challenges at various stages in development. So this ranges from predicting where to drill, tracking real-time drilling, and then monitoring wells once they're created. So you can imagine without a doubt that having analytics and AI tools helps address many of these data challenges. And altogether, that's really where TIPCO comes into play. So we've had success working with customers in the energy industry because of our hyperconverged products like TIPCO Data Virtualization, TIPCO Data Science, and Spotfire. And again, my goal today is to really show how we've used some of these products to create a complete analytics project, as well as a highly interactive dashboard. So without further ado, I'm just going to go ahead and jump into a renewable energy demo. So this demo is going to aggregate data from several sources. It's going to highlight visuals in both time series and geospatial data. And it's going to use time series and machine learning modeling to predict future energy or power production. Now, a little bit about the actual story at hand. So infrastructure teams ranging from local farm owners to energy companies need to be able to track current farm conditions and predict future power production. So here we're looking at the last 10 years of weather data in Texas. Now, research shows that the performance of both solar panels and wind turbines depends collectively on weather conditions, geographic information, and equipment information. So as data scientists, our job really is to use this collective information to best predict future energy or power production. And as always, we start off by exploring our data at hand. So it's not really that surprising that many of our weather conditions or weather variables have statistically significant seasonal differences. So here we can see that wind speed tends to be higher in the spring compared to other months. And this is just one of the differences we hope that data science models can pick up on. And in addition, I also mentioned that one of the challenges in the energy industry is the variety of data as well as the messiness of data that we're working with. So the actual wind farms that we worked with didn't have weather information at their specific coordinates. So we used one of Spotfire's readily available data functions in order to interpolate conditions from a wind farm to a nearby, from a weather station to a nearby wind farm. So here what we're actually looking at is a heat map and contour lines of where wind speed is highest in red and also where it's lowest in green. And really what we've done is interpolated weather conditions from a weather station, which is represented here by a triangle, to a nearby wind farm, which is represented here by a circle. And what I've shown so far really is a very static exploration of our data, as well as what goes into data preparation. But keep in mind that our end goal is to design an interactive dashboard for both solar and wind farm planners and owners. So this entails being able to manipulate and visualize the site metadata, the weather information over both location and time at different granularities. And for solar, our main variable of interest is called global horizontal irradiance, or GHI. So if I were to just look at GHI in the last year of 2020, I can see that it's actually highest in the West as well as the Panhandle. So collectively, this makes up the Northwest of Texas. And just to give you an idea of like the different facets of the data, if I were to select two regions, the coast and Panhandle, which are on opposite sides of Texas, I can see that GHI tends to be higher in the Panhandle than the coast. I can also see that on average, there's more capacity and investment on the Panhandle sites than the coast. And altogether, it looks like a lot of these sites still happen to be in earlier stages of completion. So they're either just areas of interest or projects that are planned. And this again is showing the different facets of our data that we want to explore holistically. And likewise, we have very much a similar page for wind. So of course, our wind variables are different. And we also want to be very intentional about what we're visualizing on a map. So as I mentioned, for the wind data, we had to pull weather conditions from nearby weather stations, and we wanted to see those adjacent to the actual farm sites. And so far, what I've really been showing is an emphasis on the geospatial aspect of our data. And another thing that we were interested in is the time series data at hand. So solar and wind farm planners and owners must be able to track current weather conditions, but it's also important for them to be able to compare weather conditions too. So here, what we're actually looking at is solar GHI, and we're comparing it in the year of 2020 across different months. And you might ask, like, why is this important for any type of planner? Well, it shows them, for example, that GHI is maybe more consistent in the month of April than it was in the month of May. And likewise, farm owners know that summer is when solar production is highest. So it's important for them to be able to compare maybe like a certain season's output against previous years. So it looks like solar GHI was highest in the year of 2020 compared to the previous years by a little bit. And we want any data science models we construct to be able to pick up on long-term changes in weather and as well as seasonal differences in weather. And overall, this time series aspect of our data just adds another layer of complexity to the existing variety of data that we're working with, as well as the spatial layer. And so far, what I've really shown is the historical data that we have. But keep in mind that for future predictions, or for planning, we do need to make future predictions. And this is really where we brought in TIBCO data science in order to test a few different statistical and machine learning models to predict the future outcome of a weather variable, GHI, from a combination of other more readily available weather variables. So here we're actually testing 3 different types of models: a linear regression, a random forest, and gradient boosting regression. And using TIBCO data science, I can easily compare these models against one another. So it looks like the linear regression and the random forest actually perform best with the lowest mean absolute errors and also the lowest root mean squared errors. If I were to dive more deeply into the random forest, I can also see the variable importance. So it looks like solar zenith angle and temperature are the most important variables in the model for the model to learn, again, for predicting GHI. And lastly, I thought it was also interesting to mention that we use TIBCO data science in order to aggregate all of our data. So this goes back to the volume challenge that I mentioned at the beginning. Our solar data set alone pulled from over 5 different sources, and we needed to quickly scale and process millions of rows of data before we could even visualize it. So again, this is another step of preparation that goes into this whole pipeline. And now that we have suitable models, it's important for us to be able to put them into context with our insights as well as existing data. So here, what we're looking at is both solar and wind data. We're looking at one solar variable and one wind variable at a time. So we're fixed on solar GHI and wind power. So the triangles here represent a wind site, and the circles represent a solar site. And the sizes of the variables actually indicate a higher value of that variable. And the colors also indicate something about the site status. So really, when you start looking at this map, what we're drawn to is actually the areas where the sizes of points are larger. Again, what we know to be the northwest of Texas. And if I were to scroll down to this bottom of this page, we can also see the time series of the variables that I just mentioned, as well as any variables that we predicted or projected appear in a different color. So there's actually an integration between TIBCO Data Science and Spotfire that allows me to constantly refresh or remodel these results so I can see them as needed. And altogether, this was really, the map and subsequent filters really allow us to manipulate the spatiotemporal aspect of our data. So keep in mind that Spotfire's map layers, as well as map charts and feature layers, allow us to cleanly and compactly view many different spatial aspects of our data.
Awesome, Sweta. Awesome job. Thank you so much for the presentation. It was insightful and it was also really beautiful. I love data visualization, so this was a treat for me. Thank you so much for walking through all that. We've got plenty of comments and questions to go through here. We'll try to take one or two questions, comments telling you that people are loving the presentation. Thank you, Tom, for joining us. We have a question here from Kimberly, and she's asking, as power moves towards a balanced integrated grid, how important will iCommunications infrastructure and cybersecurity be for creating an effective and efficient grid? What are some growing trends that you see in the space for data professionals?
Yeah, I think that's just another layer of complexity that's going to be added to our data. So it's not in our demo right now, but you could imagine that we need to be working with other types of organizations and partners to bring in, cybersecurity data to add a layer of safety, and that that's important for putting out a full project in itself. And it also adds a complexity in this data science challenge.
Thank you for that. Seriously, so many comments about how great of a demo this is. I think people were looking for a demo at this conference and they finally got it. A question here from Michelle. She's asking, are there any solar wind farms that incorporate both? I think you were showing that with the triangles and the circles,
yeah.
right? Okay.
Yeah, so there's a region in the Panhandle actually that had both the triangles and circles overlapping. So you can clearly see very clearly off the bat where there's higher GHI as well as higher wind power.
Great, thank you so much. And we'll take one more question here from Svetlana, and she's asking, how much emphasis are you putting into cybersecurity, in this space?
Yeah, so once again, I guess that's an additional component of data that we can always bring in. And the data right now is also protected and proprietary. So that's something that we also keep in mind when we're handling it as data science and also presenting it.
Great, thank you so much. Okay, before we wrap up, I just wanted to make another announcement on TIBCO. We have a course that's coming out at the DATAcated Academy called Data to Dashboard with TIBCO Spotfire. So just wanted to do a quick shout out here because we've got Dr. Spotfire himself putting together that course, Neil Kanungo. So go ahead and check that out. You'll get an email if you register for the conference with more information on that. But Sweta, thank you so much for the presentation, and thank you for taking our questions.
Yep, thank you so much for having me.
Okay, have a good rest of your day.